Alrighty, so here is 1.11b. Long division, polynomial long division, and slant asymptotes. So we're going to review a little bit of our polynomial division. But the first thing I want to note is up here at the top here, slant asymptotes. When do they occur? Well, they occur when the degree of the numerator is 1 degree higher, or just one number higher than the degree of the denominator. So when the top is bigger than the bottom by 1, and so we've got that situation right here, an x cubed and an x squared. And here's the graph of that function. And you can see we have this slant asymptote. So our line, or our curve, is getting infinitely close to it. And our curve is getting infinitely close down here, never touching it. You can remember cross it sometimes around at really any spot, but when it goes to infinity, it does just approach some number. Now, let's go ahead and find him. As I go to find this guy and figure out his equation, I do want to note here that we do have some vertical asymptotes as well. Okay, so just because we have a slant doesn't mean we don't have verticals. This one would be x equals -1, and it looks like we've got one over here at 3 as well. So x equals 3. Now let's find the equation for this slant asymptote, and then we'll look at how we can do it mathematically with our equation. So if I'm trying to find this dotted lines equation, I can find first, I know he's going to have this form, y equals mx plus b. Okay, this would probably be the easiest way to find him. And I can say, oh, his y-intercept is 1, so now I know my b is 1. And then I can also see his slope here. He goes up 1 over 1 up 1, so his slope is just 1. And so I can write this equation pretty quickly. It's just 1x plus 1, or y equals x plus 1. Okay, that's not the only way to find the equation of a line. If they give you a graph, that's awesome. But remember, you could like grab 2 points that you could read. You could write those 2 points down, 3, 4, and 1, 2. You could calculate slope here, 4 minus 2, change in y over change in x, 3 minus 1, you'd get 2 over 2, you'd get a slope of 1. Okay, so that's how you could find your slope also. So that's the equation for that slant asymptote. Okay, different than our equations for vertical asymptotes, and definitely different than our equation for horizontals, which would be y equals something. Okay. Now let's look at how we can find this mathematically. And the key is for slant asymptotes is once you realize, hey, I'm 1 degree bigger and I'm going to have 1, is to do division. Divide the numerator by the denominator. Okay, so we're going to have to practice our long division today. 2x minus 3 divided by, let's put it in black here, divided by x cubed minus x squared minus 4x, or divided into that. There we go. All right, so the key here is when you're trying to do this division and figure out your quotient on top, is you just got to figure out what you multiply this first term by to get the first term of the term you're dividing into. So in this case, I want to get an x cubed, so I'm going to have to take an x squared times a single x. And so that's what I put up here as my quotient. Then what we have to do is you have to multiply to figure out what you're going to subtract in your next step. Notice it's like a distributing thing. We have to take x times everything in our divisor. This made -2x squared, and x times -3 gives me -3x. Now comes the kind of the tricky part. If you remember how long division works, you subtract this line. Normally you just go, okay, I'll subtract. But here we have to subtract 3 different things. So you got to distribute this subtraction. So it looks like this. What you do, at least what I do, is I go, hey, okay, I'm going to distribute, and I make him a positive, and I start flipping all these signs. Because that's what would happen when I distribute the negative. And by changing this to a positive at that point, I've told myself, yep, you flipped the signs already, which is important when you're writing in pencil and you don't have colors that can tell you that you have flipped all your signs. So now that I have my signs flipped, I can just add these columns. So x plus a -x cubed, those cancel out. That's what I want to happen. Here I've got -1 plus 2, so that is a 1x squared. I've got -4 plus 3, so that's -x. And now I can bring down my next term because I'm ready to go another round here. I'm ready for the next term in my quotient up here. And so I again ask myself, what do I have to take x squared times to get 1x squared? And the answer is just 1. So I put a 1 up here. And then I distribute. And I go, well, that's x squared, or 1x squared, minus 2x, and minus 3. Strike a line, put it in parentheses, mark a subtraction, and go plus, flip them all. Boom, there they go. Add straight up and down. 1 minus 1 is 0. Negative 1 plus 2, that's 1x. And 4 plus 3 is 7. Now that's my remainder up here. Remainder is x plus 7. I know I'm done. I can't take x squared times anything to get an x. Okay? Now I want you to notice something here. And this will always be true when you're looking for slant asymptotes. Your quotient without the remainder, x plus 1, is the equation of that slant asymptote. Okay, so we're going to have to do this division to find that part. Now, I do want to point out this. When you do long division, okay, lots of times it isn't just finding slant asymptotes. We're trying to factor this polynomial. And so we use division to figure out, hey, what's another factor in it? But we also have to be able to write functions in different forms. So here's our original function written as this big long division problem. And I want to point out that after your division, what you have to write then is this is equal to your divisor times your quotient. So it is equal to the answer to your division, or I'm sorry, what you divided by times the answer to your division problem, plus your remainder, which is x plus 7, over the divisor, x squared minus 2x minus 3. So that's the equivalency when we do this long division to our polynomial, like the answer to your division problem with its remainder over its divisor. This is very similar to when you do just a regular division problem. You go 80 divided by 3, and you go 2, 6, subtract, get 2, bring down your 0. Goes in there, what, 6 times? 6 times 3 is 18. Subtract, get a 2. 3 doesn't go into 2, so you say your remainder is 2. Or you say 80 divided by 3 is equal to 26 plus 2/3, or 26 and 2/3, like that. And that's that 2 over 3, remainder over divisor. And that's the exact same thing we do here, remainder over your divisor. All right, so that's how we find slant asymptotes. We do a division problem, and we look at the quotient without the remainder. So let's try it here in example 2. I'll freeze there for just a moment, and now here comes example 2. Okay, so example 2, I check my degrees. Yep, squared, x to the first, degree is 1 higher on top. So let's do it first with long division, then we'll see the same result with synthetic, so we can review it. Now we get x squared minus x plus 2. So here I go. Pause the video and try it on your own if you want to. All right, here I go. I have to take x times an x to get x squared. Now I multiply x times x squared. Show that with an arrow. X times negative 3, negative 3x. And then I subtract. When I subtract, I go positive, negative, and positive. X squared minus x squared is 0. Negative 1 plus 3 is 2x. Bring down my 2. Now I'm going to take x times a 2 to get 2x. So I go plus 2 up here, and I distribute. There's the 2x I wanted, and the other comes out to a negative 6. And I wrap it in parentheses and subtract. And I do those sign switches here. This will be negative and positive. 2 minus 2 is 0. 2 plus 6 is 8. That is my remainder. But more importantly, y equals x plus 2 is my slant asymptote. Now, I did graph this equation so you can see it here. I'm going to pull that up. So there's the equation of f of x right there. And you can see, yeah, I've graphed the original function, that's it in the red, and then I graph that asymptote, that slant asymptote, and you can see, yep, that's how my graph fits in, going really close to that slant. Notice how, it's getting close to that slant asymptote, but its end behavior as I go to negative infinity, it's going down, down, down forever, so it still goes down to negative infinity. It just never passes that line as it heads that way. Same thing up here. As x goes to the right, it goes up to positive infinity. It's going forever this way. It just never crosses over. Okay? We can go forever in the x. I can plug in any x values I want to on this side. The only x we have to exclude is this x right here, where there's this vertical asymptote that I haven't got graphed, but it sits right in there. Okay. Let's do this now with synthetic. Now with synthetic, one of the key things is this guy down here has to be a linear, so it's got to be x to the first. Has to be a binomial, so two terms. Okay, and that's what this is, binomial, and it's a first power. Okay, and so we can set it up with synthetic. So I'm going to put a 3 in the box. Remember, you put the 0 in the box, and so 3 makes that 0, so I put 3 in the box. Then I write down the coefficients, 1, -1, and 2. Okay, so 1, -1, and 2. If I'm missing any terms, I throw a 0 in to hold its spot. Then we skip a little line here, and we draw a line. We got to leave a line for some work. And step number 1 is just bring down the 1, your lead term. Then and it's a real easy process, you multiply. You put your answer underneath your next term coefficient. So answer goes up there. So 3 times 1 gives me 3. And then you add the column 2. And then that's it. And then you do it again. You multiply using a little asterisk to indicate multiplication. I put my answer under the next one. So 3 times 2 is 6. And I add. And I get 8. And you can see, I'll slide this out of the way here. Look at that, I got a 1x plus 2 up here, remainder 8. And here's my 1x plus 2, remainder 8. We just have to make sure we know how to read that. It's just always 1 degree less. So this was x squared. I divided out an x. So it's going to be x to the first for an answer. So it's 1x to the first plus your 2. And that 8, that last thing, will always be your remainder. So there's my slant asymptote, x plus 2 again, just this part of the answer. Okay, so this is probably much quicker if we can use synthetic to find the slant asymptote. Certainly would be a big help if we're trying to graph these things, to be able to find the slant asymptote and know how your curve fits in there then. All right, so let's keep on going here. Let's see, next page. All right, normally I would tell you to give this a shot on your own, but number 3 is one that I want to go through explicitly here because, so you got 2x plus 3, and we aren't used to doing these things with synthetic division, but he is a linear binomial. So what I want to do is cover how to deal with this if you want to do it with synthetic. And the key is as follows. You want to, in your denominator, factor out that lead coefficient of 2, giving you x plus 3 halves. And so here's kind of our process. Instead of dividing 4x squared plus 2x minus 7 by this whole thing, what we're going to do is do synthetic with this part of it. And then we'll have our division answer. We just have to then divide the answer by this 2. Okay, so it's kind of a cheaty way to get around doing synthetic division when your a value is not a 1. And so we start to figure out what makes that factor down here 0, but it's just the opposite of 3 halves, so negative 3 halves. And we need that because we are going to put a negative 3 halves inside the little synthetic division box. And I'm going to write down my coefficients I'm dividing into, a 4, a 2, and a negative 7. Okay, so let's review these steps here. I bring down the 4, and now I multiply right there. Okay, and so some people get a little daunted by that. Got to do a little fraction math, but that's all right. See, this 2 in the denominator cancels out one of the 2's, and so it's just negative 3 times 2, or negative 6 here. I put my answer right there. And I just have to add those, negative 4. And I already know that 3 halves times 4 is 6. It's 3 halves times 4 again. It's going to be a 6. And since they're both negatives, it will be a positive 6 this time. So that wasn't too hard. And then I add them up, negative 1. Okay. So now I've gotten this part. I know that this over x plus 3 halves is equal to my answer here. I got this 4x squared minus 4x plus my remainder, which is negative 1 over x plus 3 halves. Okay, so that's what I did by just dividing out that part. But now I have to divide it by 2 still. So I have to divide this one by 2, this one by 2, and to divide my denominator, this last term by 2, I'll just put a 2 down there. And so I end up with the real answer, which is 2x squared minus 2x, and I've gone a little bit crazy here, sorry. This is going to be x to the first and negative 4, so this is x to the first and negative 4. Sorry if I goofed you up. And no 2 right there. There we go. So now I divide by my 2's, and I get 2x minus 2, and then I can just put plus. There's my remainder over my actual divisor. I didn't have to cut him in half at all. I just leave it like that. Or, better yet, let's put that divisor back in its original form. There we go. And here's the part, though, I wanted. There's the slant asymptote, 2x minus 2. Okay, so if you practice that skill, you'll get really good at it. How to play a little game with your 2x plus 3 so you can do synthetic. But I am going to do it with long division real quick. I won't talk you through this one. I'll just do it so you can see it. I did my subtraction there in my head. I bring down my negative 7. I take it times negative 2. I distribute, get negative 4x minus 6. And I subtract that whole line, which makes it plus 6 or negative 1. There it is, 2x minus 2. The same thing we got as with synthetic. Alrighty, the last one, we got example number 4 here. Gosh. They do have a difference degree of just 1 here. Let's just go ahead and do long division with this guy. There's ways we could try and do a little workaround with synthetic, but by the time we get done, I think it's just quicker to go with our long division. Again, you can try this on your own, but at least see the setup here. Or someone put a 0 in there. It was missing that constant term. And on the inside, I got a cubic term. I got a squared term. I'm missing my constant term, so I put in that 0. So here I go. 2 times what gives me 6? 2 times 3, and I need an extra x. So I'm going to have to use 3x. So off I go. We'll put a 3x up here, and we'll distribute, giving us 6x cubed plus 9x squared plus 0x's. We'll subtract that whole line there. So I'm going to do the old sign switcheroo. And then I go 6 minus 6, so that's just going to give me a 0 there. 13 minus 9 is 4. 0 minus 0 is 0 still, and bring down the negative 5. There we go. 2 times what gives me 4, so 2 times 2, and it's already got the x squared, so I just need to multiply by 2 here. And away we go. 2 times 2, 4x squared. 2 times 3x, 6x. 2 times 0 is 0, and I subtract. I switch my sign and I change my signs. 4 minus 4 is 0. 0 minus 6 is negative 6x, and then 5 minus 0 is just 5. So there's your remainder. And my slant asymptote, y equals 3x plus 2. You can graph that if you'd like to see that in action. And if you wanted to rewrite your whole polynomial, if they ask you that, sometimes they say, write this polynomial as a quotient and its remainder over a divisor. They even use that language sometimes. They go, well, it's 3x plus 2 plus its remainder over its divisor. Just like that. Alrighty, end behavior time. Okay, so end behavior. Gosh, I'm not sure why we wouldn't just do this the old-fashioned way and say, hey, as x gets really, really big, this equation approximates this equation. The big exponents get the rule. And then 6 over 2 is just 3, and I'll have an extra x on top. So it really just simplifies to a 3x. And so the limit as x goes to infinity, the function itself is going to go to infinity. And the limit as x goes to negative infinity, the left side, if I plug in big negative numbers, will go to negative infinity. But we can also do this with our slant asymptote, I suppose. If we find what it is, well, let's do our long division here, if I'm looking for my slant. Because they may want you to do it with slants. Not sure how they'd ask this. Is this the same one we just did? Yeah, it is. Excellent. So I don't have to reinvent the wheel here. This is the same problem we just did, and all I have to do then is draw a little sketch of it. So you can see, I didn't have to do any of that business. Now that I realize it's the same one, so 3x plus 2. Right up here, that's my slant. So 1, 2, goes through that, and its slope is up 3 and over 1. So there's the slant asymptote, just like this guy. And if you got a slant asymptote, your line's got to be as x gets really big. So as your x is going this way, you have to be approaching that line. So, you know, it could come in like this maybe, but it's going to follow that line then out just like that. Or if it comes in like this, it's got to follow that line like that. And so you just know on the top end or the right end, it's got to be going up here to infinity. And on the bottom end, it's got to be going to infinity as well. That's why as x goes this way, it approaches your curve or your asymptote. Okay, so that also gives us this same information. As I go to the right, I go to infinity, and as I go to the left, I go to infinity. And since this guy was part of 2 problems here, I'm going to graph him quick, and I'll show you the graph. Okay, so here the graph is now, and you can see, let's see if it fits our answers. I said, hey, as x goes to infinity, the function goes to infinity. Here's that asymptote. You can see it's 3x plus 2 down here. And you see, yeah, the graph approaches this thing. A lot of people think, oh, well, but doesn't it have a ceiling on it? No, the asymptote always gets higher and higher and higher, and so the function always gets higher and higher and higher. So it's going all the way up forever and ever. And on the left-hand side, you can see it going down here. And yeah, it's always pinned in front of this line or above this line, but that line's going to infinity or negative infinity, and so our graph is going there as well. So that's what it looks like. You can see there's some other things going on. It looks like there's a vertical asymptote right there. Not a surprise if we looked at the function. Looks like there's some other vertical asymptote sitting right there. Okay, so lots of things going on in that graph. Alrighty, that takes care of those. All right, the rest of this is practice. So here we can do either division, long division, or synthetic. So this would be a long division problem, a synthetic division problem. So get those tried. Use the graph of f to write the equation of the slant asymptote. So that's like our first problem that I showed you. Okay, see if you can find his equation. That's just finding the equation of a line. Same with this one. Let's see here. Determine if the following functions have horizontal asymptotes. Slant asymptotes are neither. So you're going to be looking a lot at this one, horizontal slants. Okay, so you're going to be comparing these exponents. So this one looks like this one's dominant on top. So see if we can reason out what that's going to do. These things tie. So we talked a little bit about this. And this numerator here is smaller, so your denominator wins. So See if you can figure out what your asymptotes are for those things. You can always graph them and take a peek, but try it without your calculator first. Then on our last page here, write the equation of the slant asymptotes of the following functions. So they must all be 1 degree higher on top, because those are indicative or tell us we will have a slant. So you're going to use some synthetic or long division. So we got long division, synthetic. You get to decide what you want to do there. Long division. Use the rational function to answer the following down here. Well, we've been working at this domain, zeros and holes and all this stuff. So give that a shot. And then lastly, our test prep questions. So it's kind of an interesting problem. End behavior after you've done the division with f of x. So think slant asymptotes there. 14, which of the following is equivalent? So this looks like a division problem also. We got a remainder here, it looks like. 15 is given by this, has a slant asymptote. What's the value of a? Ooh, that'll be intriguing to see if you can figure that out. Kind of neat though, you're dividing this by this, your numerator by your denominator. What's a have to be so you get this, 6x plus 3? This should be a fun one. All right, good luck.